Section 3.1, Functions and Function Notations. In this section, you're going to determine whether a relation represents a function. You're going to find the value of a function. We're going to learn how to determine whether a function is one-to-one function. We're going to use the vertical line test to identify functions. We're going to graph functions listed in the library of functions. Here's a warm-up activity, really quick. The first activity is to factor x squared minus 5x minus 24. Remember, this is quadratic expression, so it's going to factor into multiplication of two binomials. First, we factor the x, so x times x is x squared. And then we're looking for two numbers such that the product is negative 24 and the sum is negative 5. I'm thinking about two numbers. The numbers are 3 and negative 8. If you multiply negative 3 times 8, you get negative 24. If you add 3 plus negative 8, the answer is negative 5. The next activity is to solve the equation x squared plus 5x minus 14. So this is quadratic equation. First, we're going to factor into multiplication of two binomials. We factor the x times x. We need two numbers, their product is negative 14 and the sum is positive 5. So I'm thinking about positive 7 and negative 2. If you multiply them, you get negative 14. If you add 7 minus 2, or positive 7 minus 2, or negative 2 plus 7, you get positive 5. And then we need to take this further because this is an equation. So we're going to make each factor equal to 0 since if you multiply two quantities and the product is equal to 0, either of these quantities is equal to 0. So we're going to make x plus 7 equals 0. We're going to solve this equation by subtracting 7 from both sides of the equation. So we get the answer x equals negative 7. That is one of the answers. The other answer, we're going to make the other factor x minus 2 equals to 0. We're going to solve that equation by adding 2 to both sides of the equation. So we get x equals 2. So the answer is x equals negative 7, x equals 2. What is the difference between question 1 and 2? Question 1 is basically an expression. So all we did there is factor that expression. Question number 2 is an equation, which means we will need to solve that equation fully, meaning we need to figure out the value for x that makes the equation true. Now we're going to study the relation versus function concept. A relation is basically a diagram, an equation, or a list that defines a specific relationship between groups of elements such that each member of the first set, which we call the domain, corresponds to at least one member of the second set, which we call the range. That is a relation. A function is basically a correspondence or a relation between the domain and the range such that each member of the domain corresponds to exactly one member from the range. So that is the difference between the relation and the function. It is important to note that not every correspondence relation between two sets is a function, but every function is a relation. Here is an example. We're going to determine whether each of the following correspondences is a function or a relation. In order to illustrate that, I'm going to try to visualize the set. So I'm going to draw a diagram for the first relation. I will put all of the x coordinates in the first set. So I will list them. Negative 6, I have negative 6, I have positive 6, I have 3, I have negative 3, and I have 0 without repetition. Then I will take the y coordinate and I will put it in the next set without repetition. So I have 36. I'm not going to repeat 36 again. I have 9. I'm not going to repeat 9 again. And I have the 0. Now I will create this correspondence. So I know that negative 6 is basically mapped to 36. So that goes to 36. 6 is again mapped to 36. So 6 goes to 36. And then 3 goes to 9. Negative 3 goes to 9. And 0 goes to 0. So in this case, we have a relation or a correspondence such that each element of the domain is mapped exactly to one member of the range. You can think of a function as a taxi. The taxi could take people from the domain and take them to their destination, which is the range. So you see there, multiple people can go to the same destination, and that is fine. That is basically the definition of a function. So the first correspondence is going to be a function. Let's try the second correspondence. I'm going to change the color here, and I hope you have the main idea here so I don't have to explain again. So I will put the x's or the domain in the first set, and the range or the y values in the second set. I have -2 in the domain, I have 5, I have 0. I'm not going to repeat the 5 again. In the range, I have 5, I have 7, I have 1, I have -2. Now we're going to connect them. So -2 is mapped to 5, 5 is mapped to 7, 0 is mapped to 1, and 5 is mapped to -2. So you see the problem there. You see exactly what we mean by that. So there is a member in the domain where it is not mapped to only one member of the range. 5 is mapped to 2 members, and that breaks this rule right here for the function, which makes the second correspondence is a relation and it's not a function. So this is a relation and it's not a function. You can think of it as 5 is one person and the taxi is taking that person to 2 places at the same time. It doesn't work. You cannot exist, or a person cannot exist in 2 places at the same time. Lastly, I have the correspondence here, so I don't have to draw it. It's the 3 connected to the 5, the 6 is connected to the 11, and the 9 is to the 17. So clearly this is the definition of a function, because each member of the domain, which is basically the x values, is mapped exactly to one member of the range. So that is basically the definition of a function. The notation of functions. The input values or independent variables, which are members of the domain, are values of x substituted into the equation. The output values or dependent variables, members of the range, are the resulting values for y. Y equals f of x, there is a missing f here, is read basically y is a function of x, or we say f at x, or the value of f at x. This just means that y is a function of x. Okay, so that is basically the meaning of it. Okay, and for short we say y equals f of x. Graphs of functions. We graph functions the same way we graph equations. We find the order pairs x and y, or x and f of x, and then plot the points and then complete the graph, or connect the dots to complete the graph. So if we'd like to graph the function f of x equals x squared plus 1 using the table of values, we're going to create a table of values with x and f of x, which is basically the y value. And then we're going to create order pairs, plot them, and create our equation or graph our equation. So I'm going to put xy here to show you a couple examples. I like to pick 0, and I like to pick negative numbers and positive numbers. Let me do it this way actually. So I'm going to pick 1, 2, and -1, -2. Now all we need to do is to substitute x in this function right here. So remove the x value and substitute it. How do we do that? So if I want to find f when x is equal to 2, which is basically f of 2, which is the y value when x is equal to 2, I will remove the x value, replace it with a placeholder, and then put the 2 there. Now if you compute it, you get 2 squared, which is 4, plus 1, the answer is 5. Don't forget to follow PEMDAS. So the first order pair is 2 and 5. And then you remove the 2, and you're gonna replace it with the next value, which is 1. Now 1 squared is 1, 1 plus 1 is 2. So the answer is 2. The next order pair is 1 and 2. And now you remove the 1 and you replace it with the next value, which is in my case 0. So 0 squared is 0, 0 plus 1 is 1. So when x is 0, y is equal to 1. So the next order pair is 0 and 1. And then you replace 0 with the next value, which is negative 1. So replace here negative 1, negative 1, negative 1 squared is 1, 1 plus 1 is 2. So the value here is 2. We get the point negative 1 and 2. Lastly, we replace the value with 2, negative 2. Negative 2 squared is 4. 4 plus 1 is 5. So the value here is 5. We get negative 2 and 5. Now all we need to do is just to plot these points. So the first point I'm going to plot the 0 first. 0 and 1. So 0 and 1, when x is 0, y is 1, so that is the point. Then I could plot the positives and then the negatives, so I'm going to go up first. So I'll plot 1 and 2. 1 and 2 is right here, so when x is 1, y is 2. And then I'm going to plot 2 and 5, when x is 2, y is 5. And then we're going to plot the negatives, so when x is negative 1, y is 2. When x is negative 2, y is 5. So I plotted all of the points. Now all I need to do is smoothly connect these points. Because it's a curve, it's not a line. Try to make it curvy like that. And these go to infinity because those are just limited points, but we know the graph goes to infinity. You can basically graph these on your calculator, but you have to have the y side or the f of x on one side, or you can graph it on Desmos, basically, desmos.com. You can go and you can graph it right there. The vertical line test. We use the vertical line test to test whether the graph represents a function or not. If it is possible for a vertical line test to cross a graph more than once, then the graph is not a graph for a function or of a function. Because as you can see here, let's look at, let's say, this graph right here. If you look at the value here, the value is just for 1x. There is a 1 value for x here. But that value corresponds to y1 and corresponds to y2 as well. So I have a value in the domain that has 2 values in the range. So it looks something like this. So that is not going to be a function, and that is why the vertical line test works. So let's look at these graphs and see which one is a function and which one isn't. The first one, obviously, if you test it with the vertical line test, it is not possible for the vertical line test to cross the graph more than once, so it is a function. The second one, I can test this point right here, and I can see that the graph is crossed 3 times, which means this is not a function. The next graph the next graph, the line vertical line test, fails because it crosses the graph twice, so this is not a function. Same with the circle. If you perform the vertical line test, it's going to cut the circle in 2 points or at 2 points, crosses it at 2 points, which means it's not a function. The next graph, if you perform the vertical line test, you will notice the graph crosses, or the vertical line test crosses the graph just once, so this is a function. And the last one, this vertical line test is not going to fail. And there is one troublesome point that you have to check, which is basically this point right here. So let me make it in red. This point right here. So if the graph cuts here, if this was not an open circle, I would have said this is not a function, because basically the line, the vertical line test is going to cross the graph at 2 points. So it fails the vertical line test. However, because there is an open circle right here, that means the graph actually doesn't cut the vertical line doesn't cut the graph twice. It cuts it only here, and it doesn't cut it in the next point. Here, you can see here there is an open circle, as you can see. So even this point, which is a troublesome point, you can clearly see that the vertical line test doesn't fail, so this is definitely a function. Next, we're going to learn how to find the output values of a function. When we know the input value and we want to find the corresponding output values, we evaluate the function. When we know the output values and we want to determine the input values that produce that output value, we set the output equal to the function's formula and solve for the input. So, for example here, if we want to evaluate the function f of x equals x squared minus 3x minus 10, and we want to evaluate the function at 2, that is basically f of 2 means what is the value of the function when x is equal to 2, because that replaces this x right here. So what we do here, we remove each x. I'm going to put a placeholder instead of the x. I like using parentheses because they prevent me from making mistakes. So, and then I will place the 2 inside of these parentheses. Now I will follow PEMDAS. So I will do what's inside the parentheses first. It's already simplified. And then I will do exponents. So it's going to be 4. And then minus 3 times 2 is negative 6. And then minus 10. And then we do addition, subtraction as we see them. So 4 minus 6 is negative 2. Negative 2 minus 10 is negative 12. Same with the second one. So we will replace every x with a placeholder. And then we replace the negative 2 inside. Very important to include the parentheses, especially if you're dealing with negative numbers, because if you don't include the parentheses, especially if you're using a calculator, you're going to end up not squaring the negative and having the wrong answer or the wrong outcome. Negative 2 squared is positive 4. Negative 3 times negative 2 is positive 6. And then minus 10. Now, 4 plus 6 is 10. Minus 10 is 0. When we have a variable instead of the number, we do the same exact process. Times open and not minus 10, and then we place the variable inside. I know that a squared is a squared. Negative 3 times a is negative 3a minus 10. Notice we don't have any like terms here, so we're going to keep this as it is. It is the simplest form. How about negative a? We put the placeholders and then replace the negative a inside and see what happens. Negative a times negative a is positive a squared. Negative 3 times negative a is positive 3a, and then minus 10. Notice the difference between the first one and the second one. That is the only difference here. Next, if we have negative and f of a, we already found f of a. Here is f of a, that is number 3. All we need to do is take the final answer and multiply that with negative 1. So I'm just going to say negative outside and then put the answer that I got from part 3, which is a squared minus 3a minus 10. Now, we need to distribute the negative inside. We get negative times a squared is negative a squared. Negative times negative 3a is positive 3a. Negative 1 times negative 10 is positive 10. Notice how these are not the same. Number 4 and number 5 are not the same. So f of negative a doesn't have to be negative f of a. It does not have to be that way. Finally, we want to solve for f of x equals to 0. So we're going to remove f of x and we're going to replace that with 0 and solve. We get 0 equals x squared minus 3x minus 10. This is quadratic function. This is a quadratic equation. We're going to factor it first, or we can put the 0 on the other side if that makes it better. We factor the x. We need two numbers. Their product is negative 10. Their sum is negative 3. That is negative 5 and negative 5 and positive 2. And now we solve each factor. So we make x plus 2 equals 0 and solve. We make x minus 5 equals 0 and solve. We get x equals negative 2 and x is equal to 5. So that would be your final answer. Determining whether a function is a one-to-one function. A function is a one-to-one function when each output value corresponds to exactly one input value. There are no repeated x or y values. We will come back to this concept later in the semester, as well as the horizontal line test, but you're more than welcome to read up on it now if you wish to. We're going to use the horizontal line test to determine whether the function is one-to-one function. So the horizontal line test says if there is a possibility for the horizontal line to cross the graph more than once, then the function isn't a one-to-one function. If the horizontal line crosses the graph just once, then that function is a one-to-one function. So for example, the first graph here, the horizontal line crosses the graph just once, so this is a one-to-one function. While the second one, it crosses it twice. I know that is a graph of a function because it passes the vertical line test, but it doesn't pass the horizontal line test, so it is not a one-to-one function. It is a function, but it's not a one-to-one function. So that is basically the definition of one-to-one function. Again, we're going to cover this concept later on in the semester. And finally, we're going to identify some basic toolkit functions. We will be using these in the future in order to translate and move and reflect these graphs. So make sure you know what the graph is and how it looks like. So try to memorize as much as you can. The first function is the constant function, which basically f of x equals to a constant, any number. In this particular example, f of x equals 1, 2, 3, so equals to 3 in this specific example, but it could be any real number on the number line, okay? The next function is the identity function, which is basically this line right here. This is the identity function where f of x is equal to y, or f of x is equal to x, or x is equal to y, because f of x is equivalent of y. The absolute value function, f of x equals the absolute value of x, which is the v shape. This is the famous v shape. The quadratic, we got to deal with the quadratic before. So this is the quadratic function, f of x equals x squared. It has to have the x squared term, and it looks like a parabola like that. The cubic function, f of x equals x cubed, which is going to look like this with one arm up and one arm down. And then we have the reciprocal function, f of x equals 1 over x, which contains two parts. Here is one part and here is the other part. The square root function, f of x equals square root of x, which looks like this. And then the cubic root is f of x equals cube root of x, And then the reciprocal squared function, which is f of x equals 1 over x squared, which it has two parts and both of them are above the x-axis because it is squared. So both of them are positive and above the x-axis. That concludes section 3.1. If you have any questions, let me know.